This is experiment number 2, that is feature selection and feature extraction. So feature selection is the process of selecting the most relevant features from the data set and remove irrelevant or redundant features. And in feature extraction, it is the process of transforming existing features into a new set of features. So, in feature extraction and feature selection, we use different methods to make the data more precise and accurate so that we get accurate results. Here, so firstly, we read the data set, that is wine quality feature.csv file. Then the next step is we are supposed to drop the columns, chloride, and free sulfur dioxide. So we create a temporary variable, that is temp.df, then a copy of the actual data set, and we drop the uh, columns, chlorides, and free sulfur dioxide. Then the shape or the size after dropping columns is found. Then the numerical columns with outliers are found, and the columns are dropped. And the size after dropping the columns is supposed to be found. And to detect the outlier, we use the constraint as IQR. That means interquartile range. So we create a copy and an empty list of outlier columns is created. Then we calculate the Q1 and Q3. Q1 is the 0.25, that is 25% of the data, and Q3 is the 75% of the data. Q1 minus Q3 minus Q1, that gives IQR. So if we are supposed to find IQR, we need to use this formula. Then if temp BF2 of call is less than this value, that is the lower bound value, or the value is greater than the upper bound, then the outliers are appended, that are added to the given empty list. Then the outlier columns are dropped for further analysis. The next question is, we find the numerical columns with variance that is less than 0.5 and displayed. So we are displaying the columns which have the variance less than 0.5 and the size is displayed. So low variance column is citric acid, and the size after dropping this column is 50,1. Then the input columns with less than zero point 0.1 correlation with target column quality, and we are supposed to display it. Correlation is how well one variable is related to another variable. So the columns which have lesser correlation, that is less than 0.1, that is supposed to be identified over here. So in this data set, there is no correlation column. That's why it gives an empty list. Then drop the columns with less than 0.1 correlation and display the size. So we are supposed to drop the uh, columns with low correlation. Since there are no correlation, the size of the low correlation, the size of the data set is 50,1. Then we identify highly correlated input features with correlation that is greater than 65%. So we create a correlation matrix to store the values, and we use dot for function, that is correlation and highly correlated pairs. An empty list is initiated, store the highly correlated pairs, and if the correlation matrix is greater than 0.65 and it is equal to quality, then it is appended to the empty list created. Since there are no highly correlated feature pairs, it gives an empty list. Then drop one feature from the highly correlated feature pair. So we if this temp BF4 dot call temp df4 of quality is less than temp4 dot call temp4 of quality, then drop features dot append of f1. We have to drop features. If we find one feature from the highly correlated pair, but since there are no highly correlated pair, nothing is getting dropped. Hence, we are getting the same size over here. We are separating input features and target features. That is the dependent variable and independent variable. Univariate feature selection. Univariate feature selection is a selection based on one single variable and select k best. That is, the best features are selected using uh, k, the particular k. So since k is equal to 5, we select k is equal to 5 here. And from scikit-learn, we import select k best and chi-square test and min-max scalar. So min-max scalar is used for standardization of the data, where the standard deviation is equal to 1 and the mean is equal to 0. And fit transform is performed. Fit is training the model and transforming the data into 0 or 1. And hence we get top 5 selected features. So selected features are these are the since k is equal to 5, we get top 5 features which are highly correlated and which can be helpful in determining the actual prediction. Then we find the mutual information score. Uh, then mutual info classic. This is the function where we use to find mutual information score. Mutual information score is a score which tells you how the feature is connected or how the feature is different from the actual labels and the predicted labels. The mutual information score for the given values. So 0.241279. Highest mutual information scored feature is pH. And then we perform feature extraction using PCA, that is principal component analysis. This is a technique of dimensionality reduction. And here we create a standard, that is standard deviation. We find standard deviation. Then a covariance matrix is found. This T is the uh, transpose of the matrix. Eigenvalues gives the directions of the values, and eigenvalues are the magnitudes, and eigenvectors gives the direction of the values. Then IDX is the indices of the eigenvalues, which is sorted in order. Then uh, eigenvectors use the indices to calculate the principal components. Then it starts from first two values of eigenvectors. Then we find the output, that is dimensionality reduction is done, and we find the output, that is PCA output shape is 50,2. Then we perform a feature extraction using LDA. LDA stands for linear discriminant analysis, which takes the first two LDA components over here, and it is also a supervised uh, dimensionality reduction technique. In this linear discriminant analysis, we use the function from the scikit-learn, that is linear discriminant analysis, and we consider the first two components. Then fit transform is done for the scale data, that is the data is trained and it is transformed to the particular values. Then the output is found, which is 50,2. Then we have to read an image delta.bmp and extract the pixel by pixel mean feature and display it. In this, we import the CV2 library. The CV2 library is imported, which is known as OpenCV, Open Source Computer Vision Library, which uses the grayscale. Uh, by pixel, first it converts into grayscale, and if the image, when it calculates the mean of each pixel, of every pixel, and then gives the output. So the mean pixel value of an image is 107.68. This pixel by pixel mean feature is used for image processing and the computer vision tasks. And then we use the RGB values, that is red, green, blue values, and we find the mean pixel value of the image. Thank you.